In Lesson 1-4, you will be evaluating expressions involving absolute values and solving absolute value equations. How can an absolute value equation describe the magnitude of an earthquake? Seismologists use the Richter scale to express the magnitudes of earthquakes. This scale ranges from 1 to 10, 10 being the highest. The uncertainty in the estimate of the magnitude E is about plus or minus 3/10 of a unit. This means that an earthquake with a magnitude estimated at 6.1 on the Richter scale might actually have a magnitude as low as 5.8 or as high as 6.4. These extremes can be described by the absolute value equation. The absolute value of E minus 6.1 equals 0.3. The absolute value of a number is its distance from 0 on the number line. Since the distance is non-negative, the absolute value of a number is also always non-negative. The symbol absolute value of x is used to represent the absolute value of a number x. For any real number a, if a is positive or 0, the absolute value of a is a. If a is negative, the absolute value of a is the opposite of a. And, okay, that says the same thing in symbols. So absolute value of a equals a if a is greater than 0, and absolute value of a equals the opposite of a if a is less than 0. And this is a nice model. They're showing 3 units from 0 on either side. When we evaluate where there was an x, we're going to replace it with the value of x, which they said was 4. So we have 2.7 plus the absolute value of 6 minus 2 times 4 is 8. So 2.7 plus absolute value of 6 minus 8 is negative 2. And finally, we can do our absolute value. Absolute value negative 2 is 2. And 2.7 plus 2 is 4.7. The first way we solved absolute value equations in Algebra 1 was graphically, so we're going to look at that real quickly. We need to look at, the center is going to be what makes us get back to 0 there. So it's going to be centered around, in this case, negative 3. So it's the opposite of this number. And then I want to go 8 units to the right and 8 units to the left of that number. And so this is a graphical approach. And I got the 2 solutions of 5 and negative 11. Most people prefer an algebraic approach, and this is when we used our case 1. So case 1, we just dropped off the absolute value, and so we're assuming that we're going to the right. Case 2, we're going to do the opposite of what's in the absolute value. So y plus 3 equals negative 8, so that's my move 8 places to the left. Now that we have case 1, case 2 set up, it's easy enough to solve. Subtract 3 from both sides, and I get 5. Subtract 3 from both sides, and I get negative 11. So these are always going to have 2 solutions. And I'm using braces instead of parentheses because it's not an ordered pair. Order doesn't matter. You could just circle your solution. That would be fine too. I made the mistake of saying always 2 solutions. Oops, there are 2 exceptions. Because the absolute value of a number is always positive or 0, an equation like the absolute value of x equals negative 5 is never true. It has no solution. The solution for this type of equation is the empty set, which could be symbolized by braces with nothing between it, or most people like the null set notation. So if you're alert, this type of problem works very quickly. So subtract 5 from both sides, and we have absolute value of 6 minus 4t equals negative 5, and you could be done. Now, I tend to go ahead and do case 1, case 2, and then I check, and I find out it doesn't work, and I'm very sad. So pay attention, and this is a very quick problem. So we're going to start right off with the case 1, case 2. This one's interesting because it's not just one number on the right-hand side. So I'm going to have 8 plus y equals, that's a plus, not a t, just 2y minus 3 just as it is, or we could have 8 plus y equals the opposite of the right side, so it's going to be negative 2y plus 3. And then the solving is no problem. We're going to get y on one side, so 8 equals y minus 3, and add 3 to both sides, so 11 equals y. And get y on one side. I'm going to add 2y to both sides, I think. So 8 plus 2y equals 3. Subtract 8. And I have 2y equals negative 2 divided by 2. And y equals negative 1. To check, we're going to substitute 11 back in where the y was in the original equation, and I get 19 equals 22 minus 3, which is a true statement. So that one worked. Here I'm going to substitute negative 1 in where the y was, so now I have 7 equals negative 2 minus 3. 7 equals negative 5 is not a true statement, so negative 1 is not an answer. So our only answer that time is 11. Summing it up, for any real numbers a and b, where b is greater than or equal to 0, if the absolute value of a equals b, then a equals b, or a equals the opposite of b.